So it has started it.
Okay, so students, today we are starting canonical form. So very important uh, section of partial differential equation. So please pay attention. Canonical canonical form of first order linear partial differential equation. So linear partial differential equation. Okay, so why are canonical forms important over here? In partial differential equation, suppose you get any partial differential equation which is not easily solvable. You are finding its solution very complicated. So what we do, we first try to change that in the canonical form, and canonical form will help you to have simple integration. Okay, so this is the importance of canonical form. कोई भी difficult equation अगर आपको मिल रही है जिसको you are facing difficulty in solving, so first you are going to convert into the canonical form, and then you will integrate. So integration of canonical form is very simple. Let's see. So before that we need to have some review. We need to have some review of chain rule basically, though you have idea, but let's recall. So please pay attention. This requires a very good attention, then only you will be able to understand. And believe me, if you won't pay attention, you might not be able to do by self-study in this chapter. Okay, so chain rule. Before chain rule, let's know about the following two symbol. Uh, this is the one symbol which is known as Jai. So which is known as Jai. Okay, and then there is one more symbol. This is known as eta. So I have given my best to write Jai and eta. So if you can write it in a better way, please do. So this is known as Jai and this is known as eta. So Jai you can also write in this way. This will also work. Anyway, so these are the symbols only. So if we are given u as a function of Jai and eta, u is a function of Jai and eta. U is a function of Jai and eta, where Jai and eta both are further dependent on x and y, or you can call they are function of x and y both. So we are on the step one of chain rule. In next chapter, it will become slightly complicated. So you have to understand step one first in order to know the step two later on. Okay. So now I'm interested in finding the ux and uy. So ux and uy I have to find. But I cannot go to x directly because in between you have xi and eta are also function of x. So who will tell me what is going to be ux? Yes, who will tell me? We already have idea about this. बताओ. In order to differentiate u with respect to x, so first what are you going to do? You will differentiate with respect to what and all. Am I there?
Yes, sir.
Yes, sir.
Okay, so first we will differentiate this with respect to xi only. First, we have to differentiate this with respect to xi. So del u upon del xi. So I'm writing in the subscript form u xi, and am I done? Am I done on this line? Look, am I done on this line? Not yet, because xi is also further dependent on x, right? So xi is also further dependent on x. So I will have del xi upon del x also. Yes, someone has to be on mute, I guess. So this I have dealt with this option now. So am I done with respect to x? Am I done with respect to x? Have I differentiated with respect to x completely, or do we need to add something more?
Something more is added. uh, y का भी
Yes.
आएगा ना अभी.
नहीं
Sorry,
नहीं
eta
with
का.
respect to x.
Sorry,
हाँ, eta.
sorry, eta का.
Eta का we will have to have, because eta is also function of x. So plus u eta, but eta is also further dependent on x, so you cannot leave eta behind. So del eta upon del x. So this is, now we are done. Now we are done. So first I want to go to this xi, and then xi is also for function of x. Then I will go to eta, but eta is also function of x. So now I'm done with all the options of x. So if you want to write this in del u upon del xi into del xi upon del x plus del u upon del eta into del eta upon del x. So you can write in that form also. Okay, so please tell me, how will I differentiate? What will be the differentiation with respect to y now? Batao.
U xi
U xi
xi y
xi y
plus
plus
u eta
u eta
into eta y.
in, into eta y. Yeah, that's right. Thank you. So this is going to be the partial differentiation of u with respect to y. So if you have any problem, students, just let me know. So do not get confused with the notation. So I am writing this first one with respect to del. So first one can also be written as del u upon del xi into del xi upon del x plus del u upon del eta into del eta upon, okay, this is eta upon x, del x. So this is how you can write. Can you write it also in this notation? So someone else, some new volunteer we require. Please tell me, how are we going to write this in terms of del? We require a new volunteer here.
Del u upon del phi
Del u upon
del xi,
del xi,
then multiplied by del xi upon del y
del xi upon del y,
plus del u upon del eta
del u upon del eta.
multiplied by del eta upon del y.
Yeah, thank you. So this is how you can write. So ux also you can write del u upon del x on left hand side, and uy del u upon del y. That's fine. Okay, so we will require Jacobian also here in this method. So Jacobian will also be required. Jacobian will be required. So Jacobian is nothing but, okay. So if I denote this, so Jacobian is going to be, have you done Ronskin in ODE? Xi x, Xi y. Please tell me, have you done Ronskin in the ODE?
No, sir.
No, sir.
Okay. So you will require Ronskin over there, this Jacobian over there. So one of the most important chapter of differential equation, I must say. Forget PD, OD. One of the most important. So at least one or two questions you will get from Ronskin in all competitive exams. Anyway, so this is going to be the Jacobian of xi and eta, but xi and eta are function of xy. So you are allowed to replace x and y also respectively. So you can write in this way also. So Jacobian of xy you can write uh, as a, so in this way also it can be written as, so this is del xi upon del x and del xi upon del y and del eta upon del x and del eta del y. So in this way also you can write del xi eta upon del of x y. So this is also a notation simply. But what you have to know mainly, this you have to know. This 2 cross 2 determinant you have to know. So let me write in terms of del. So del xi upon del x, del xi upon del y, and del eta upon del x, and del eta upon del y. So this is known as Jacobian. Okay. So this is known as Jacobian. And later on, since you have not done this Ronskin now, so if in order to check something is linearly independent or dependent, you are going to check is this determinant of this is zero or non-zero. So if zero, linearly dependent; if non-zero, linearly independent. Okay, so that we will see. Okay, so now the procedure of solving first order linear partial differential equation. So procedure, call it procedure or working rule. Or working rule. So this procedure you have to remember. You will be given procedure throughout differential equation or working rule. So you will know that and then you will solve the differential equation. Sometimes they will mention that use this method, sometimes they don't mention, then you are free to use any method. Okay. So you will be given linear differential equation. In fact, the Cauchy linear partial differential equation. So given the Cauchy linear partial differential equation. So this will be given. So what type of differential equation you will be given? Something f1 ux plus f2 uy is equal to right hand side. I'm calling it h. I'm calling it h. Some book, some book on right hand side they use two terms and they say so they define in terms of p q, then they write r plus s. But right hand side I am denoting with h. So uh, right hand side is always right hand side because on right hand side you must have observed till now on right hand side if you have term of ux and uy you bring on left hand side first and you are left with the terms of not having ux and ui. So that can be called by one symbol only. It's up to the mathematician to mathematician. Some people divide that also. So what something like this is written x plus xz. So they call it some r plus s. But you can also call this with one symbol. That's what I'm doing over here. So this is the game of notations only. Is that fine, students? So this type of differential equation we will be given and let's see how can we solve. Step 1. Step 1, write down the characteristic equation. So in step 1, we are going to write the characteristic equations, and that you already know. So what will be the characteristic equation over here? Who would like to tell us?
Del U by F1.
So this is going to be dx upon f1. Okay, and this is going to be dy upon f2, and on right hand side you will be having du upon h. So the following are going to be the characteristic equations. Okay, so first you will write the characteristic equation. This is going to be our step number 1. Then step number 2. Step number 2, solve first is equal to second. This is the rule, students. Solve first and second. So first is equal to second only. So first is equal to second. So this is first, this is second, and this is third. So first is equal to second we are going to solve. To get phi xy is equal to some constant. So when you will solve, so you can call that phi xy is equal to some constant. Some constant. Okay. So this is step 2. Now step 3. In step 3, now I will introduce the new symbols xi and eta. Okay, so xi and eta I must have to introduce keeping the following rule in mind. So let xi is equal to phi xy. Phi xy you will get in the second step. You are going to assume it is equal to xi, and eta we will assume equal to y. Eta we will assume is equal to y, or vice versa can also be done. So if you want to do xi is equal to x, and eta is equal to phi xy, that choice is also available. It's up to you. Okay, so that why I'm choosing xi and eta, so that j, that means Jacobian, is not equal to 0. And if Jacobian is not equal to 0, what can you say about xi and eta? If Jacobian is not going to be 0, what can you say about xi and eta? They are going to be independent, students, linearly independent. Since you have not done Wronskian, so let me tell you, if Jacobian is going to be 0, then they are going to be dependent. That means they are going to be scalar multiple of each other. But if Jacobian is non-zero, then they are not linearly dependent. That means linearly independent. Hence, they cannot be written as a scalar multiple of the other. And I require xi and eta as independent function. Okay. Sometime when you choose this option, you never know, you might not get independent. Then you have to look for the second option. Is that fine, students, still here? Okay. So what is my aim? My aim is to convert my differential equation in terms of xi and eta, but they must be independent, and that I will check with help of Jacobian. And in order to have independent, Jacobian हमारा नॉन जीरो होना चाहिए. So let me complete this step also. So and and transform transform the given PDE, the given PDE and transform the given PDE into one with xi and eta as independent variable. As independent variables. Done. See students, you must have noticed that our original differential equation is given in terms of x and y. Okay. So in step 1, you will find out the characteristic equation. There is no problem at all. In step 2, you will solve first is equal to second also, and you will get some solution. Call that solution as phi xy is equal to constant. That is also going to be an easy task. Step 3. In step 3, what he is saying that I will introduce new symbols xi and eta namely, and the following are the procedure. So either you say xi is equal to phi xy we will get in the step 2, and then eta is equal to y you have to let, or you let eta is equal to phi xy, but then xi is equal to x you have to let. Okay, then we will check is Jacobian going to be non-zero or zero. If it is non-zero, then our procedure is right. We can proceed further. But in step 3, our equation will turns out into xi and eta. Okay, and the time you will get your equation in xi and eta, that is known as canonical form. Okay, that is known as canonical form. So either he will say that reduce this differential equation to canonical form, then we are done at step 3. But if he will say also solve, further also solve, then we have to solve also. This is the procedure of solving first order linear canonical form, PDE, basically with the help of canonical form. So or let's have, so let's solve one question, then you please ask if there is any doubt. So after solving the question you will get more clarification. This is very easy. Okay, let's solve one question first. So this is question number 30 on, so exercise 2.8 and page 319. Okay, so this is an unsolved question, so let's do this first. reduce Reduce this differential equation into canonical form. Reduce the PDE into canonical form. And find the general solution. So we have to solve also and find the general solution. Okay, so what is the differential equation? This is given as ux plus uy is equal to u. So this is the given partial differential equation, right? So let's follow the procedure now. Let's follow the procedure. So step one, write down the characteristic equation. So the characteristic equations, so the characteristic equations are what are going to be dx upon the coefficient of ux, which is 1, dy upon the coefficient of y, which is again 1, is equal to du upon right hand side, that is going to be u. That is going to be u. So this is over step number 1. Very easy. Now in the step number 2, 1 is equal to 2. So step 2, take first is equal to second. So what do we get in that case? So when I will solve first is equal to second, so let me write dx upon 1 is equal to dy upon 1, and you get x minus y is equal to constant. So call it C1. Of course, where C1 is arbitrary constant, where C1 is arbitrary constant. Okay, students. So step 1 and step 2 we have done. Now let's come to this step 3, the important one. So step 3. So let xi is equal to let xi is equal to phi xy. So this is my phi xy, this solution. So if you want to name it phi xy, say this is equal to phi xy, that's also fine. So let xi is equal to phi xy, that means xi is equal to x minus y. Okay, if I take xi is equal to x minus y, that means phi xy, then I have no choice. I will take xi is eta is equal to y over here. Okay, and then what will be the x and y? So if you will solve, x is going to be xi plus eta. Why xi plus eta? Because y is given eta. Is that fine, students?
Yes, sir.
So because y को हमने eta दिया है, so x will become xi plus eta. Okay, have I got independent choice of xi and eta? That I will check now. So for that I will check Jacobian, and in Jacobian, so what is the formula of Jacobian? You have to remember this. You have to mug up del xi upon del x, del xi upon del y, del eta upon del x, and del eta upon del y. So बताओ then what will be this 2 cross 2 matrix? What is going to be this 2 cross 2 matrix? Del xi upon del x. So that will become 1. I'm differentiating this with respect to x. And then del xi upon del y. So that will become what? If you will differentiate this with respect to y, so
minus
what do you get? Minus 1. And similarly, if I differentiate this with respect to x, so what will I get? 0. And when I will differentiate this with respect to y, I will get 1. And this determinant is going to be 1, which is not equal to 0. So clearly, xi and eta are
alike.
xi and eta are alike. So clearly xi and eta are alike, linearly independent. So you will be calling them Li throughout. Okay. So now in order to convert my given differential equation in terms of xi and eta, I will find ux and uy and then I will substitute over here. So chain rule I have to apply. So chain rule I will apply. So by chain rule, so what is the ux over here? So ux is nothing but u xi, which you have already done, into xi x plus u eta into eta x, and everything is given above. So please differentiate them. So this is going to be 1. So xi x is going to be 1. So 1 into u xi plus u eta x is what? 0. Eta x is 0. So 0 into u eta. And this is nothing but u xi. Do you agree or not, students?
Yes, sir.
Right. And similarly, let's calculate uy. Similarly, let's calculate uy, and uy will be what? U xi into xi y plus u eta into eta y. And please solve this from above, and you will see this is nothing but u xi plus u eta. So this is what we will get. How come? Because del xi y हमारा आ रहा है -1. Yes, xi y you can get from here -1, right? And eta y you are getting 1. Do you agree or not, students, from here? And by replacing the following value, this you will get. And now replace this in the given differential equation. So now equation number 1, which is the given one. So what is that? Ux plus uy is equal to u. So let's replace ux and uy over here. And what do we get? So we get u xi, this is ux, plus uy. So this is minus u xi plus u eta is equal to u, right? And now what is getting cancelled? This is getting cancelled. So I am left with u eta is equal to u. And this is the required canonical form, students. So this is the required canonical form. So if he will say reduce to canonical form, then we are done. But he is also asking us to find out the general solution. So that's easy now. That's very easy. So if you are given this differential equation, so just integrate simply, you will get the solution. You will get the solution. And this is the advantage of canonical forms. Sometimes your differential equation is so complicated that you cannot solve easily, but this differential equation turns out to be very simple. Just compare with the given differential equation. Don't you agree or not? Though this is a simple example I have picked up, but still just compare equation number 1 and this required canonical form. So this is very easy to solve. So let's find out the general solution now. So this is nothing but del u upon del eta is equal to u. So I am going to integrate this with respect to what? Batao. We have to integrate this with respect to. So this is we are given student del u upon del eta is equal to u. So I must integrate this with respect to what that I will get my answer in terms of u. Batao. I have to integrate this with respect to which symbol that I will get u in picture over here on right hand left hand side.
It is del u by u equal to del eta. If you
Yes.
log
So you can write del u is equal to del u is equal to this also can be written uh, u
del
u
u
I
by
can
u.
bring over here.
Yes, sir.
U I
Equal
can bring here and del eta.
eta.
Okay. So let's integrate this with respect to eta.
U by
So
eta.
integrating with respect to eta basically. With respect to eta. Okay. So what is this going to be? Log u is equal to eta plus constant. So I'm taking in terms of log because log is there in picture. But what is going to be the constant? C1, C2 or something like that? No. This is going to be the function of xi. Do you agree or not, students? Right now your differential equation is in terms of eta and xi. So if you are integrating with respect to eta, then xi will be treated as a constant. Do you agree or not? Are you getting? I am
Yes, sir.
integrating with respect to eta, then the other independent variable will be treated as a constant. Whatever you do in the partial differential differentiation, the same you will be doing with respect to integration also. So function of xi is going to be the constant. Please tell me, have you understood this step or not? Function of xi is going to be constant. I'm writing in terms of log because I want to make calculation simple. If you want to remove log and you just want to write f xi, that's also fine. That's also fine. But since I want to make calculation simple, so log constant I have written. Is that fine, students? I repeat, I repeat. This is the differential equation given, and now we are in the symbol of xi and eta. So in order to get solution of this differential equation, I am integrating with respect to eta. So then xi will be treated as a constant. So log u is equal to eta plus constant, and that constant is going to be function of xi. Please let me know if you have not understood. And now done. So this is nothing but log of u minus log of fji is equal to eta. And now log a minus log b, you already know. So log u upon function of xi is equal to eta, and therefore you will get u upon function of xi is equal to e raised to power eta. That is u is nothing but e raised to power eta fji, where f is an arbitrary function, where f is an arbitrary function. Okay, so we are done, students. We are done. Finally, you may replace xi and eta in terms of x and y. So if you want to do that, that can also be done. How? How come? Because this कहाँ गया? Yes, xi is nothing but x minus y, and eta is nothing but y. So you want to get your final answer in terms of x and y, that can also be done. So we are done with this example, students. Now, if you have any query, please ask. I will scroll down the uh, screen slowly. You can ask me to stop and you can ask questions. So throughout this same procedure, you will apply in your exercise. We will be doing more questions. Don't worry. Yeah. Is that fine? Yes, students. Am I there?
Yes, sir.
So all the questions, you have to follow the same rule. So we have 9 more minutes. Let's do this question. So procedure you have to remember. You must have noticed this in the in this paper of differential equation, that even if you do the theory, at the end to solve questions you have to remember the procedure. Okay. So our next question is, so let's solve this example. Ux plus xuy is equal to y. Please solve this differential equation, students. So step one, write down the characteristic equation. So my solution may not be complete, so you will be doing on your own. So write down the characteristic equation. So dx upon 1, dy upon x, and du upon y. So this is going to be the characteristic equation. Now consider 1 is equal to 2. So step 2, consider 1 is equal to 2. So dx upon 1 is equal to dy upon x. And please solve this differential equation.
X square minus 2y equal to constant.
Yes, thank you. So x square minus 2y is equal to c1. Let's call it c1. Of course, where c1 is arbitrary. Okay, so what is going to be my next task? In step 3, I have to introduce
Xi
over
and eta.
xi and eta. So in step 3, so let's choose our simple one first. Okay, so he has taken, as per my notes as I can see, so he has not taken xi is equal to fxy this time. That xi is equal to x square minus 2y and eta is equal to y. This choice he has not taken. Maybe there could be both the cases. Either it is not getting the Li1, Jacobian might be coming out to be equal to 0, or calculation is becoming difficult. So this you please check at home, students. So, but I have told you, you can take the vice versa case also. What he has done over here, So he has taken xi is equal to x and eta is equal to phi xy, जो solution हम लेते हैं in the step 2. So that's also fine. So eta is equal to x square minus 2y. So this choice I am taking. I am not denying. I am not denying that this choice cannot be taken, but we have to work on it. Then only we can make conclusion. Is that understood, students? Is that fine till here?
Yes, sir.
Someone needs to reply. Okay. So the following symbols I have chosen. Let's find out the Jacobian now. So Jacobian is going to be del xi upon del x. Okay, let me write del xi upon del x. You have to remember at the end, but I will try my level best. You will remember it from class itself. And del eta upon del x and del eta upon del y. तो ये हमारा जैकोबियन होता है. Xi and eta both are given. So please tell me what is this 2 cross 2 determinant, students?
1,
1,
0,
0,
2x,
2x,
minus 2,
minus 2. And what is the determinant of this? Minus 2,
minus 2.
which is not equal to 0. Hence, the choice of xi and eta will be suitable for us. They are alike. So therefore, don't worry, we will get some question where you will get Jacobian 0. So then we will see what all changes can we make. So are alike. Okay, now let's apply the chain rule, because in the given differential equation I have to replace ux and uy, also value of x, but x I have taken is equal to xi. But let's find out ux and uy, because I have to write in the given differential equation. So ux is going to be what? So batao, have you remembered what is ux? Any smart student?
U U eta
No.
U xi U xi U xi
Uji,
xi
Uji,
into
ja-
into
into
xi x xi x
into हाँ.
plus U eta eta x.
Yes, yes, thank you. So let's replace the following value, and after replacing the following value you get Uji plus 2x U eta. Okay, done. Who else will tell me the new volumeter we require? What will be the UI? बताओ.
U
U,
xi
Uji,
xi y
Jai Y,
uh, then U eta
U eta.
eta y.
Yeah, I have written it wrongly. You type okay. I'm changing the role. Though you were right. So since I did not want to undo, so Jai Y, Jai you Jai. That's also fine. Is that also fine, students? Or I have made mistake?
it is correct.
It is correct. Only I have changed the order. Okay, no problem. This is coming out to be minus 2 U eta. कहाँ से लेते हैं हम दिस फ्रॉम हियर यू कैलकुलेट जाई एक्स जाई वाई और eta x eta y and then replace over here you will get the following equation. Is that fine, students? From here you will get xi x xi y eta x eta y, replace उनको यहाँ करो and this is what you will get. Now replace them in the given differential equation. Okay, so replace them in the given differential equation. So what do we get? Please verify that do we get this or not. U xi plus 2x u eta minus 2x u eta is equal to y. देखें एक बार. So my given differential equation is ux. What we have got ux? Uj plus 2x u eta. So have I written this? Yes. Uj plus 2x u eta I have written. Then we have x into uy. So uy is coming out to be minus 2 eta, but x also we have to multiply. That's fine. And is equal to y. So this will get cancelled. This will get cancelled. So we are left with u xi is equal to y. Is that fine, students? Okay. And now I have to get this in terms of xi and eta. So what he has done, let me see. Y is going to be huh, yes, from here we are getting. So if I want to calculate y from here, so y will be what from here? Y will be eta minus x square, minus minus 2. So that change we will make accordingly. Is that understood, students? I can replace y is equal to this in my given differential equation. Is that fine? And x is also given xi. So since I will make here plus, so here plus, here minus, and x I am replacing with xi. So xi square minus 4 upon 2. I think आपकी class होगी, मुझे ये लग रहा है. So please try to solve this now on your own. We will be doing in the next class. So those who want to leave can leave. I just give you the solution. So this can be written as xi square minus eta upon 2, because xi and eta you are getting from the this replacement only I have made. Now integrate, and you will be integrating with respect to xi. Do you agree or not? Because you have u subscript xi. So you are going to integrate with respect to xi only. Have you understood this step, students?
Yes, sir.
So this time you are integrating with respect to xi, because you have u subscript xi. So differentiation if you want to remove, then integration is going to be in picture. Okay, that's okay. Now please try at home. Done. Thank you. You can leave. If you have any question, please stay back. Otherwise, we are done. Please stop recording.